In the last lecture, we looked at maximum likelihood estimation, which gives you one way to do point estimation. If we have prior beliefs, can we use that in maximum likelihood estimation? No, because it only looks at the data instances to estimate your parameter values. So if we have prior beliefs, then we have to do it another way, and that is called the Bayesian way. Here we don't estimate a single value of theta, but we obtain a distribution over possible values of theta. So for example, if we have some prior belief which looks like this, we use this prior belief and then also observe our data instances, which we did for MLE. We combine that with this prior belief to get our estimate. So essentially, we use Bayes' rule. And how do we use it? We have prior belief, which is P of theta. Some prior on theta, right? So only theta is involved in the prior belief. And then we have likelihood. Likelihood is P of D given theta. What is the probability of D given theta? What is the distribution of the data given that it is governed by theta? So this one we saw, this quantity is what we used in MLE, right? We used this quantity likelihood in MLE. That's why it's called maximum likelihood estimation. So we are combining this and prior. So now we already have seen Bayes' rule. So using the likelihood and the prior, we can arrive now at the posterior, which is a distribution over theta. Which also considers D, which is our data instances. And to arrive at this, we also need a normalization, which is P of D. So this is coming from Bayes' rule. P of D given theta times P of theta by P of D will give us our posterior P of theta given D. So theta given D is our estimate. So remember, when we did maximum likelihood, we used P of D given theta, and then we found out the value of theta. Value of theta, which maximized P of D given theta for MLE. Now, that gave us a value of theta. And now, when we have a distribution over theta in the form of a posterior, we get a distribution. We don't get one single value, but a distribution. So that is the difference between maximum likelihood estimation and using Bayesian learning to do estimation of theta. In most cases, P of D is hard to compute. So we approximate this by saying P of theta given D can be approximated or is proportional to P of D given theta, P of theta. If our prior is a uniform prior, then there is no additional value the prior is adding. And in that case, P of theta given D reduces to the MLE objective, which is D given theta.